Welcome to Unlock Layouts. In this video lecture, we are going to discuss how to do the base level layout of SRAM cell. It's a continuation video from my part 1. Let's start the video. In our previous video, we have discussed how is the RAM cell and how to plan for the signal routing. Now, this is our part 2 video. If you have not watched my part 1 video, kindly I am requesting you to watch the part 1 video so that you can easily able to understand this part 2. The first important information is what we have to know here. You have two different signals here. The one signal, the type of signal is called bus signal. The one more type of signals are called non-bus signal. So in the schematic itself, if you see something called a wider line of metals like this, and wherever you see something called a 0 is to some number, 0 is to 159, and opposite side some RWL signal. My RWL signal is also 0 is to 127 and WL signal is also having 0 is to 127. So these signals are called bus signal. Other than that, we have some other nets. Okay, something called PC here. So this PC is only 16 signal, but this is not a bus signal. And then we have a VSS and VDD, power signal. Okay, so the first golden rule which we need to follow here. Whatever bus signals we are seeing here in the layout, bus signals always has to be routed from the top and bottom. For example, the bus signals always has to be routed from vertically we need to route. Okay, see for example now here I have output signal and then 4 input signal and then I have a PC input signal. So except my PC, all the signals are bus signal. So whatever the signals is there in terms of bus signals always has to be routed from top and bottom like this. Okay, the signals has to be travel from top end to the bottom end. Okay, the signals has to be all the way, it has to travel from top to bottom. It should not end between the layout. Okay, then already we know that we have a 6 signals here. We have a input signal, we have output signal, we have a input 1, input 2, input 3 and input 4. So totally we have 5 signals here. Then additionally we have one more signal for PC. So totally in this area, whichever the signals are bus signals, I have reserved all the signals as a vertical routing. See 1, 2, 3, 4, 5. So all the 5 signals as a bus signals, I have previously allotted the area and I reserved the area for this bus. Okay, but this is my theoretical routing, but anyway theoretical routing cannot be 100% implemented in the practical layout. So this is my practical layout which I am going to use it in my layout. Okay, so I have my first signal, this is my bus, RBL is a bus, BL is a bus and BLB is a bus and RW is a bus. Okay, the reason why I have created some pending of the metals here. So here you can clearly see some of the metals are pending. It's not directly routed as a straight line because see whatever anyway I told you we need to very tightly route the areas here because we don't want to waste the area. So this portion whatever it is there here, this portion I have reserved for my power signal routing. Okay, anyway power signal will be routed on M5, but here even though the power signals are routed on M5, this power signal has to be attached with the lowest metal. What is my lowest metal here? Maybe I'll be using M1 to M3. So M1 to M5 I need to add via here. So in order not to create any type of DRC violations in this place, I have separated these metals as a pending. So I have reserved this area for power. Top side I am using for VDD, even bottom side also I have reserved some area for the power vias. Okay, so this power vias I am using for VSS. Okay, this area is reserved. Maybe by using this image you may not able to understand this very clearly, but in the practical layout this will be very easy to understand. Okay, let me show that in few seconds. Then what is the golden rule we have to follow here? The 6 golden rules we have to follow for the memory layout. First, all the bus signals has to be routed always vertically, it should not be horizontal. Non-bus signals are there, it can be routed horizontally also, it can be routed vertically also, depends on the case. Okay, we can decide. Then always we need to use some of the minimum metal width. Maybe in my PDK minimum metal width is 0.1, but I am choosing 0.12. okay, so here in metal 3, this metal 3 is having 0.12 as a metal width. Then the metal to metal distance is also here. Theoretically I have maintained the metal width for here 0.12, but theoretical routing is really not possible. Actual routing will be like this. Okay, but in case if it is possible to route as a theoretical routing, you can follow the same way of routing, but practically it is not possible. Then again, wherever we are interconnecting two metals, always use minimum 2 square vias. 1 square via is not allowed in the memory layout. Not only in the memory layout, any digital circuit 1 square via is not allowed because it's a purely DFM rule. rules, okay, design for manufacturability rules. Now there is a possibility of failure one square via at the time of manufacturing. There are more number of failure possibilities, okay. It may fabricate properly or it may not fabricate properly. So in order to avoid the DFM rule, try to use always minimum 2 square vias in every places, in every interconnecting places. Then the metal orientation strictly we need to follow, okay, maximum try to follow the metal orientation in order to avoid some collisions in the top level. Same way here I am planning to take non-bus signals as a M2 and bus signals in M3, and power always I am planning to take it on top metal, that is my M5 level, okay. M5 vertically power also need to be routed, VDD and VSS. Then reserve some area for the power hookup in the top level. This is very much important, okay. We need to reserve some area for the power hookup. So that's what I discussed in the layout. So this particular portion I have reserved this area for the power hookups. So after seeing the real layout, maybe you can able to understand how I am going to utilize this power area. So in this T-2 level already we discussed that this is the base level schematic. So this base level schematic only we need to reserve all the signal routings, right? So now here, what are all the non-bus signals here, okay. Just come to the top level of one more level here. See, WL signal and RWL signal, these two signals are my non-bus signals. So non-bus signals I am planning to take horizontally. Then whatever the signals are bus signal, BN, BLB and RBL, these three signals I am planning to route vertically in my layout. Then not only these three signals, and top level layout, one more level up, see here in this one more level up, totally we have 5 signals of the bus. So inside the subblock level itself we need to reserve the routing places for these extra 2 buses also, okay. So in such a way that we need to create our memory cells. So now the layout is already completed, okay, because the doing a layout from the scratch level will take a lot of time. So I have completed the layout already, but just I will show you how I have created the layout. Now I will create OD layer, and as well as I will enable only M1 layer. So top side I have reserved some area for VDD taps, and bottom side I have reserved some area for VSS tap. So this is how we will create tap connections in the standard cell. The same way we need to create tap cells, bottom for VSS and top for VDD, okay. You can swap the terminals also, you can keep VSS in the top and VDD in the bottom, that doesn't matter. Then again, signal routing, and one more golden rule what I told you, wherever I am using, I am always try to use 2 number of vias. See, most of the places I always used 2 square vias, I have never used 1 via. See, most of the places I have used 2 vias here, okay. Nowhere else I am using the square vias of single square via. Then again the golden rule number 2 is also satisfied. Then again signal routing, coming to the signal routing of M2, okay. See, RWL signal and then my WL signal, both signals are non-bus signals, right? So non-bus signals I have routed horizontally, from left to right I have routed the signals. Then bus signals, already I told you we have a totally 5 signals in the top level, so 5 nets we need to route vertically. See, in my level I have only RBL signal, then BL signal, then BLB signal, only three signals are there. But in top level I have 2 signals, okay. So I have reserved the metal routing inside the subblock level itself. This is my T-2 level, but these routings are effectively going to utilize in the T level, that is my top level, or maybe T-1 level. But inside the T-2 level itself I need to reserve the area for here. And moreover, this block always I need to maintain some minimum DRC between metal to metal, that is 0.11. Somewhere I cannot maintain minimum DRC, so that doesn't matter. That's what we discussed in the previous video. Like, we cannot always maintain the minimum DRC, or we cannot maintain the theoretical routing structure here. Then one more important thing which I wanted to show you, I told that this place I have reserved for my power routing. Now I'll explain how I'm going to utilize the power. See, my M5 metal is already routed here, okay. This I'm going to use it for power. But if I add some via here, for example, if I create some auto via, and if I add some via here, I told already minimum 2 vias are needed. If I add 2 vias in this particular area, see, for example, now this portion, if I want to add 2 via, then this via will be stacked from M5 to M3 metal, right? So let me show you one by one, layer by layer. So this M3 needs some minimum spacing between M3 metal to M3 metal. So now here my M3 to M3 I am maintaining 0.12, and left side also I am maintaining 0.112. The minimum distance between the metal 3 to metal 3 is 0.12. So in case if I routed this metal straight away without pending this metal, I cannot place this via here, okay. That's the violation of the golden rule. Then again, even though if I try to place this via here, I cannot supposed to keep 2 contacts here. See, here I have maintained 2 contacts. M3 contact is also 2, M4 contact is also 2, okay. 2 contacts I have maintained here. So in order to avoid this collision, I just created the different way of routing, okay. I just created some small pending of this metal, I just routed in another side, okay. So this is the reason I have bended this metal. But in your layout, in case if you have any proper place to keep your power via, or in case if you are not supposed to bend any metal from your side, you can follow that rule. But in my layout, I am following this structure. That doesn't mean you can also do the same. And as well as the bottom side also, this portion I am going to utilize for my VSS connection. But anyway, VSS via at this point of time I am not going to place, okay, because this will create some problem now. Okay, anyway, now even in this condition also, with this level we cannot able to understand. One more t-1 level you can able to easily understand this. So now I'll delete this via, because this via is not needed at this point of this level. Okay, then again one more important rule which I need to explain here. For example, now we have a PP layer, we have a NP layer, and we have a M1 layer. Okay, see that all the layers of PP, NP and M1 should properly maintained as a square, right, or rectangular. No layers are overlapped with each other. No layers are having extra area compared to other metal. See, for example, now this PP I can keep it like this also. Okay, so I can keep it like this, but this is not allowed in the memory layout. Okay, whatever layers you are using, all the layers should come and touch in the PR boundary, exactly where you have the PR boundary, including all the metals. For example, if you are using any M1 metal, okay, for example, now I am going to the M1 metal, all the M1 metals should come and touch here. See here, M1 metal. Then again I am enabling my M2 metals also. Okay, the signals which is non-bus signals also, it has to come and touch the PR boundary, edge to edge PR boundary. Not only left side, also you need to maintain right side also. Both the side, left and right edge, the signal should touch exactly to the PR boundary. Okay, then here, see, there is a small problem with M1. So what I can do, I can just simply extend this metal one. That's all. All the metals compulsory, it has to create a contact in the edge to edge contact. Then again coming to M3, okay, because these are all non-bus signals. Non-bus signals are routed horizontally, so left edge to the right edge, the signals has to be routed within the PR boundary to PR boundary. Then again I'll enable M3 metal. See, this M3 metal also we need to maintain the same rule. The M3 metal also should come and touch the bottom PR boundary to the top PR boundary. Okay, so top PR boundary to this bottom PR boundary. So see here, all the M3 layers are coming and ending in the top side, and then the metal starting from the bottom side. Okay, so the metals, whatever the bus signals or non-bus signals are there, both the signals has to be always touch left PR boundary to right PR boundary, and top PR boundary to the bottom PR boundary. And as well as the power as well, the power signal also has to follow the same rule. The power signal also I have planned in the bottom PR boundary to top PR boundary touching. Okay, but you may not able to understand this properly because this is the base level floor plan. But once I come to the T+1 level, you can easily able to understand the reason why I kept this metal flow started from PR boundary to PR boundary. That means left to right and right to left. Okay, let me save.
I hope I have given some valuable information to you in this video. Thank you for watching my video. If you like this video, please click like button and share this video to your friends. For more details about this video, please contact us to my email ID and follow us on my Facebook page and Twitter page, and kindly subscribe our channel, and don't forget to click the bell button.